Hi everyone. Till now, I have mentioned that let's create this model as a table or let's create this model as a view, or I have frequently used the term materialization, as in if we go to our dbt underscore project.yaml file, we can see that we have used this word materialized multiple times and we have used table or view till now. But we have not talked about what exactly is this materialization and are there other materializations present or not. So in this particular video, we are going to be diving deep into what is materialization in dbt. If you're new here, then I'm Radhika and this is my YouTube channel Datazard. We've been continuing our dbt series, and in this particular series I cover one dbt topic in a single video and I release videos every Thursday. If you're liking this series, then please put your feedback in the comments below and show your love by clicking on the like button. If you haven't subscribed already, then I would encourage you to subscribe as well, as I don't want you to miss out on any future videos. And now without further ado, let's get started. Let us start with the first question as to what is materialization in dbt. You know that previously we have been creating models. Now these models, they will go into the data warehouse. Now when they will go into the data warehouse, materialization is something that decides how this is going to be stored or it is not going to be stored in the data warehouse. So this materialization, it decides the storage strategy. Now we have already used two types of materializations. The first one is a table. So when we create the model, it goes into the data warehouse and a table gets created. The other one is a view. These were the only two that we were using. But there are two more materializations that are available in dbt. The first one is called as incremental and the last one is called as ephemeral. So materialization is like asking, when I run the model, what should I do with the output? Should I create a table? Should I create a view? Should it be an incremental table or it should be ephemeral? We're going to dive deep into each one of these, but I want to give an analogy with the help of which it will be very easy for you to understand what these materializations are. So I'm going to be taking example from the cooking world because I love to cook. So I'm going to take an example of a scenario where consider that you're running a restaurant. In a restaurant, you will have a lot of dishes. Now these dishes, they can either be made at order, so it is prepared fresh. The other dishes could be prepared in batches and then you're just serving these to customers. The others could be prepared incrementally, like you need to keep a stock of certain amount of curry. If the curry goes below a certain threshold, then you re-prepare the curry so that you bring that stock up so that you serve all the customers. So this is kind of that incremental preparation. And the other one is just like chopping veggies, doing some prep work. So this will not go into your menu, but this is essential so that we can prepare all the dishes. So it's the prep work. So this is the same core idea behind materializations as well. So the way to think about this is, when you create a view, if you're coming from the SQL background, you would already know that when a view is queried, like when you select star from a view, then in that case the data is fetched on the go. The data is not prepared already. The query runs again and fetches the data. So you get the freshest data possible. So you can think about this like if you're running a restaurant, then when you're making dishes at the time of order, when somebody is ordering it, at that time you're preparing it. So that's how these two relate. So view and made at order, this is how I'm making an analogy between them. Second one is about batches, which relates to creating a table as materialization in dbt. When we are preparing dishes in batches, then what we are doing is we are preparing dishes beforehand and then we are just serving at the time when the customer is ordering. Similarly, when we create a model as a table in a data warehouse, that table already exists. The data already exists about that particular model. When a stakeholder is querying that particular model, then all the data warehouse is doing is it's just serving that data to that particular stakeholder. It's not, it may be stale data because that data has already been prepared. So that is why I'm comparing preparation of dishes which are done in batches in restaurant to how a model is created as a table in dbt. Third one is the incremental one. So like I used an example where after a certain threshold, if the dishes or if that curry falls below that threshold, then we're going to re-prepare it. Similarly, in the incremental materialization, what happens is, suppose that we are going to send data till today, whatever has happened, like whatever data that we have from our operational database into the data warehouse. Now tomorrow there would be some deletions happening, there could be some updates happening, there could be some inserts happening. These are all the changes that could happen to our data. So what we are going to do is, tomorrow, instead of reloading the whole data set into the data warehouse till tomorrow's date, what we are going to do is we're just going to bring these deletes, updates and insertions into our data warehouse. So we are going to build them incrementally. So if today, let's say we had 50k rows and tomorrow we have 60k rows, suppose that we are only adding the data to our operational database, we are not doing delete or updates to make the scenario simpler. So there are 10k rows that were added today. So tomorrow I don't have to load 60k rows of data. I can just load these 10k rows and my model would be up to date. So this is how incremental models are built. And the last one is the ephemeral models, which I am tying back to the prep work that we are doing at a restaurant. So like the prep work, you don't see, like we don't directly give chopped veggies to the customers in a restaurant, but those veggies, they go into different dishes. Similarly, when we are creating these ephemeral models, we are not going to query these models directly, but we're going to use these ephemeral models inside different models. So let's say there is a complex calculation that needs to happen for a particular scenario. So that calculation you can do outside, create that model as an ephemeral model. You cannot query this model, but you can reference this model, which is an ephemeral model, into other places where that calculation is required, so that you don't have to build that logic again and again. So this is how I am tying the materialization with how dishes are prepared in a restaurant. I hope this gave you a clarity of what are the different materialization, what are the pros and cons. We are anyways diving deep into each one of these, but I just wanted to give an overview so that you know what's coming in the upcoming video. Let us start from view materialization. Suppose that this is your restaurant. Here customer comes and they said, please bear with me with my drawing. I'm not good at it, so I'm just trying. So customer walks in and they said that they want a pasta. Now this order is taken by the waiter and then they will go to kitchen. Now in kitchen, chef is there. Chef knows that this is the recipe for this particular pasta. They will follow this recipe, prepare this pasta, and then they will serve it to the customer. So you see here we have this recipe and we are creating this on order. We are creating this fresh. Similarly, for a view, what happens is, suppose that this is your model in dbt and it is created as a view. So what will happen is, suppose that there is a stakeholder who is querying this data. Now in this view, you already have the SQL select statement. It is already written. So when stakeholder will query this view, this statement will get executed and your data would be prepared. And then this data would be served to the stakeholder. So you're running this statement every time on your raw data, preparing the data like your tables are created, and then you are giving this to a stakeholder. So this recipe is like this SQL statement. You already have the recipe, but you are running this on the raw data on the fly. You're preparing this data and then serving it to the stakeholder. So if I have to explain what happens technically, then essentially this virtual table gets created. This is not the data that is physically stored. It is created on the fly and it remains virtual. Every time somebody is querying this particular model, that is created as a view, they are running this underlying SQL on the raw data. And because we are running this SQL every time on the raw data, it will always show the latest data because we are querying the raw data again and again. Now let us try to understand some use cases for views and when not to use a view. Let's first start with when to use a view. A good scenario would be when you are at the prototyping stage so that you always get the fresh data. Second is when your underlying data changes frequently and you always want fresh results. So creating a view model is helpful because every time you query this model, you will get fresh data. And last scenario is when you're querying a small amount of data and your query runs fast, then it is okay to create a model as a view. But there are situations when you should not be using a view. So one of those scenarios is when your raw data that you're querying every time you're querying this view is very large. If it is very large, this view is going to be querying a very large data set. And if you're doing this very frequently, like there are 10 stakeholders doing this 10 times a day, it's 100 times a day you're trying to query this view, which means it could result in expensive queries because you're doing this a lot number of times on a very large data set. So that's when you have to keep a tap on whether we should be creating this as a view or not. Now let us talk about some advantages and disadvantages of using a view. So the most important advantage of using a view is that stakeholders will always have fresh data available. And there are two important disadvantages when it comes to views. First one is if there are any complex transformations that are happening in that particular view, then the query could be slower, especially if you have large data set. And also if you are querying a view on top of a view, like there is a particular model which is a view and there is another column which is also a view, and you're calling view 1 in view 2, then this will make the query slower as well. So these are some of the disadvantages of using a view. Now let's move on to our second materialization, which is a table. With tables, let's first understand this with the restaurant analogy. So this is our restaurant and what will happen is there will be our chef in the kitchen. So this is kitchen. Here we have our chef and this chef is going to prepare a dish in batches. So this is batch created for, let's say, particular curry. So this happens, let's say, at 7 a.m. in the morning. The chef does this at 7 a.m. in the morning. Now there is a customer that is walking into a restaurant and they are asking for this particular curry. So what chef will do is chef will just pour a bowl out of this and then serve this to the customer. So in this way we already have the data prepared, like we already have the dish prepared, but we are just taking out and serving this to the customer. This is exactly what happens in the table as well. When you're creating a model, so let's say this is your model and you have created this as a table. So when you're doing the dbt run command, what dbt is doing is, if this table already exists, like if this model already exists in the data warehouse, it will first drop it and then it will run this create table statement again, like this, it will create this model again. So create model again, drop from the data warehouse, create in the data warehouse, and then it will store these results like the physical table in the data warehouse itself. Previously we did not had any physical table, but this time because it is a table materialization, we are creating this particular table, whatever is coming in, and we are storing this in the data warehouse. Now if a stakeholder is querying this particular model, then what dbt will do is it will just get this table and show it to the stakeholder. So always remember that whenever this dbt run command will run, It will first drop any table that is existing, like it will first drop this model from the data warehouse if it exists. Then it will create the model from scratch, and then it will store it in the data warehouse. So the results are stored and kept in the data warehouse as physical tables. And then when stakeholder is querying this particular table model, then these results, they are shared with the stakeholder. Now let us talk about what happens technically when you use a table materialization, just to recap everything. dbt will first drop the old table and it will rebuild it from scratch on every run. Now this data will be stored physically in the data warehouse, and the queries will be faster as the data is already sitting. When the stakeholder is querying the model, all the data warehouse has to do is present that data to the stakeholder. Data freshness will depend on how often we are running the dbt commands, that is dbt run, because when this will be run, then only the table will get updated with the recent data. Otherwise, we will be showing the user or showing the stakeholder the data that was updated in the previous run. Next, let us also talk about when to use table materialization and when not to use a table materialization. So if there are models which are going to be frequently queried, then they should be created as tables, because in that way we are storing the results physically into the data warehouse, so that whenever they are queried, then we just present the results to the stakeholder. When the full rebuild does not take too long, then it is okay to create models as tables. Why? Because let's say if there are millions of rows, they will take longer to rebuild. Maybe hours of time would be taken to rebuild all of the data. So that might not be an ideal use case. So think about, if the rebuilding time is less, then table materialization should be good. When you don't mind your data being slightly out of date between the runs, then it is okay to use table materialization. And tables, when they are queried by BI tools, we would want the BI tool to show the data instantly. In that case, we should be using table materializations to show data on those BI tools, so that they are very instantaneous rather than they taking time to load the data and then present it in the form of visualizations. So these were the use cases when you should be using the table materialization. There is one use case that I can think of where we should not be using table materialization, and it is when the tables, they are huge, like millions and millions of rows, because the build will take more time. So this is why you should think about, is there a better materialization that I can use instead of a table materialization. And lastly, I would like to cover advantages and disadvantages of using table materialization. So coming to advantages, you might have already guessed it, that the queries will run faster, dashboards will get served instantly if we are serving them using a table model, and it has low waiting time. The dashboards, they have low waiting time, or the queries will take low waiting time, because the data is present already, we are just serving it. The disadvantages, the main ones are, models can take long time to rebuild, especially if there are lots of rows present, like millions of rows present, and also when there are complex transformations involved in those models. So you need to understand whether this materialization is the right materialization, because this is one of the main drawbacks. And the other one is latency in the updates. If it is okay to have some latency, then it is okay to use table materialization. Otherwise, it is one of the biggest disadvantages of using a table materialization, that there could be latency in the updates. Now let us move on to our third materialization, which is incremental. So for incremental materialization, let us go back to our cooking world example. Suppose that the chef comes on Monday morning and prepares curry, 100 bowls of this particular curry. Now by Monday evening, these bowls, they are just left to 80 bowls. There are 20 that have been consumed. So on Tuesday, we already have these 80 bowls. What the chef will do is, he will just cook 20 more bowls, so that bowl count for this particular query goes to 100, because every day we want 100 bowls to be prepared. So if you see here, the chef did not discard these 80 bowls. He just made whatever was the difference between 100 and 80, just 20 bowls. He did not make the full, not all the 100 bowls. So this is exactly what happens in the incremental materialization. So suppose that this is your raw data and it currently has 50k rows. Now, when you're building a model, which is incremental model in dbt, what you will do is on your day 1, you will load this full data. So you will load 50k rows on day 1. Then suppose that this is day 2 and now you have got 60k rows, and in these 60k rows you have 10,000 rows that are updated as well. So there are 10,000 rows that were newly added and there are 10,000 rows that have been updated. So in all, there has been a change in 20k records. 10k have been added, 10k have been updated. Now you already have this incremental model. So on day 2, we are not going to load this 60k again because this is not the way incremental works. In incremental, we will be bringing those 10k records which were updated, and we will be bringing the 10k records which were new. So we are only bringing the changes. We are not loading this full data set again. In this way, we are reducing the number of rows that we have to bring in each time. So this is what's the purpose of incremental. The first day the dbt runs, it will load the full data table in the model, and from the every next run, dbt will only process these new rows or the new changes that have arrived into this model since the last run. So we are just inserting or updating the new records into the table since the last time the model has run. That's it. Let us now try to see what happens technically in incremental materialization. So like I said, for the first run, dbt will build the full table just like it was doing this for the regular table materialization. Then from the subsequent runs, dbt will only process and append the new or changed rows. So it will not reload the full data set again and again. And because it is just appending the new rows or the changed rows, you will have to define to dbt that what do you mean by new. For example, you can say that if the created date is greater than yesterday, then you bring in all those changes into your data warehouse in this particular model. Or when the modified date is greater than yesterday, then you bring in that into the model. So this is how you can define incremental materialization. Now next, let us look at when to use incremental materialization and when not to use incremental materialization. So the use cases for incremental materialization is when you have an event style data or you have transactions data. So this data will grow every day, and it is that type of data where you can have a created date or a modified date. So you can get this data into your data warehouse as an incremental materialization model strategy. If any of the table model is taking too long to build, then what you can do is you can convert that table model into an incremental model so that you're only bringing the updates from the data into your data warehouse. You are not rebuilding the model from scratch by loading everything. If the ingest layer table has a lot of rows, like millions of rows, billions of rows, then the best strategy would be to use incremental materialization rather than a regular table materialization, because in that way we are just bringing in the changes rather than loading those millions or billions of rows every time the dbt run happens. There is a use case where we should not be using incremental materialization is when the tables are too small. We should not be overcomplicating things, and this is also one of the dbt's best practices, that we should only use incremental materialization when we see that there is a degradation in the performance. If we see the things are working fine, builds are taking average time, then we should not be creating any models as. Now the last thing that I would like to cover for incremental materialization is the advantages and disadvantages. So the main advantage of using incremental materialization is that the build time for our models is reduced because we are only getting the changed or new rows from the subsequent runs. So this is the biggest advantage. The disadvantage is that it requires some additional configurations which might be hard to configure or later on debug. So that's one of the disadvantages. Best practice is first we should always use the table materialization, and if that doesn't work out, then just convert that into incremental materialization. Now let us talk about the ephemeral materialization. So in the kitchen, this is your kitchen, and the chef is gonna come and they're gonna do some prep work. So the prep work would be like chopping onions, then mincing some garlic, preparing some stock. So they would be doing all of this work. And when the customer orders, they're not gonna order this chopped onion or minced garlic. They're going to order a particular dish. However, in that dish, this prep work is gonna go. Some of the chopped onions could go in a dish, some of the minced garlic could go in another dish. So this prep work is helping build that particular dish that the customer is ordering. This is the same logic that we use in dbt for ephemeral materialization. So suppose that we are building a model, and this is model M1, and this is actually a table materialization. Now the query here is so complex, and there is one piece of logic that is very complex that we are using over here. Then we create another model M2, and this same logic will have to go in here as well, and we are writing that logic again over here. Now if you see, if later on this logic changes, then we will have to go into model 1, we will have to go into model 2 and make changes. However, what if I'm making this model, this logic as a model of its own? So this model would be an ephemeral model. I don't need to query this logic separately. Like I don't have a necessity to call this model separately, but it can go into M1, it can go into model M2, so that first of all becomes more maintainable, because we just have one place to go to if the logic changes. We just have to make changes in the ephemeral model, and these two models would be good on their own. Second, it helps in making the model more readable, because instead of building these complex logics in the models themselves, we are building it outside and we are just referencing them. And the way to reference them is using a CTE. So in this model M1, we're going to have a CTE for this particular model, and just the same way other CTEs work, we're just going to reference it. And at the compile time, dbt is going to get the code for this particular model into this M1 model, and then it's gonna run. Now the thing is, this model can never be queried, and it doesn't sit into a data warehouse. It's not gonna go over here. It's going to come into action when we compile the code for this particular models, because this is where we are referencing it. So this model is like a prep work. We are only using it in the models that need it, but this model will never be queried on its own. So let us now try to understand what happens technically in ephemeral materialization. So dbt is not going to create any object in your data warehouse for this particular model. Like when you create your table materialization or a table model, a table gets created. When a view model gets created, then a view gets created in data warehouse. When you create incremental models, then another table gets created in the data warehouse. But for these kind of materialization, ephemeral materialization, you will find nothing in your data warehouse. You wouldn't even know it exists. Second, instead what happens is the SQL will get injected into your compiled code, and this is directly done by dbt. You're going to reference this model as a CTE in another model, and at the time of compilation, dbt is going to replace your referencing with the code from this particular model. So you're just referencing it, you're not calling it directly. Now next, let us talk about the use cases, when to use and when not to use ephemeral materialization. So let's start with when to use ephemeral materialization. If you're going to have some transformations which are simple and you're going to be using in your upstream model, like when after you're ingesting, after that in a couple of models if you're using them, then it is okay to create those models as ephemeral materialization. And if you're not going to have to query any particular model directly, then it is okay to use ephemeral materialization for the model. However, when we come to the where not to use ephemeral materialization, if you're going to use too many chains of these ephemeral models, then it's going to complicate your SQL. So it will be hard to debug and maintain. So maybe avoid in those scenarios. And if any piece of data you will have to query it separately, like to understand the logic or just query it directly in the data warehouse, then you should not be creating those as ephemeral, because nothing is going to exist in your data warehouse like we discussed earlier. Lastly, it's about advantages and disadvantages of ephemeral materialization. So the two important advantages are it is reusable piece of logic. You can use it in different places, and it also helps to keep the data warehouse less cluttered or clean, just because we are not loading things into the data warehouse which will not be queried by directly. So it helps to keep the data warehouse clean. There are a few disadvantages though, that we cannot query that model. It could be an advantage as well as disadvantage depending on what you want to do with it. Because we cannot query these directly, so they are harder to debug. If you are overusing these ephemeral materialization models, then it could be that the queries, they are again hard to debug, or the models in which these are used, they are hard to debug, because then there will be lengthy piece of code added replacing these ephemeral model citations. Also, there are some operations like dbt run operation. We have not seen this till now, but there are macros which we call using these. They cannot reference the ephemeral models. That's one of the limitations. We're going to look into these later on in the videos, but it's a good to know thing, I guess. I have taken all of these from the dbt documentation itself, so please feel free to look at the documentation to get up to speed of what's the latest and what are the things that I have not covered, as there is plenty of things that you can do in dbt. But that's pretty much it. I'm going to end the video right now over here. We're going to look at the implementation side of things in the next video, so please watch this space. As always, please let me know your feedback, good, constructive, whatever you feel like saying to me, please let me know. I would love to hear from you. So please put that in the comments below. Thank you for watching. I will see you in my next one.